Okay, so why do we care about this? And I'm going to be beating on this through the whole semester. I am convinced that understanding dimensional analysis will vastly improve your understanding of applied mathematics. If you understand how variables are related to each other dimensionally, you'll start to see how equations just start to make sense. Instead of having to memorize them, you will see how the terms, why they have to be in the numerator, why they have to be in the denominator, and why that all works. And we're going to go through many examples of that over this semester. In fact, I would add that the most important skill for being good at applied mathematics is dimensional analysis after algebra. So the two things that make you really good at applied math is number one, being really good at algebra, number two, understanding the dimensionality of the variables in that algebra. Also, it dramatically reduces the potential for making mathematical errors, and that's two kinds of errors. Basic calculation errors, and I'm sure this has been harped in other quantitative classes you've taken. Be sure you carry units through calculations. I'm going to beat on that in this class too. I don't want to see any work on calculations without units going through the math because that is a form of dimensional analysis and it shows you whether you're making a fundamental calculation error with the algebra that you're using. Also, if you get into the business of deriving your own equations, understanding dimensionality of the terms really helps you understand if you made a mistake. A dimensionally consistent equation is one that has the same dimensions on both sides of the equal sign. If you come out with an answer from a derivation where that isn't the case, but you know it is a dimensionally consistent equation, then you know you've made some sort of error in your derivation. So it's a really important skill for catching errors in mathematics quickly, both in terms of numerical errors and in derivation errors.